Good morning, everyone. It's a pleasure to be here. I think I can start. Yes. So, yeah, my name is Pietro Casella. I'm part of EQT Digital team. This is a team at EQT, a private equity firm, where we really have three main missions. So one mission is to actually make ourselves a state-of-the-art company in terms of digitalization. Another mission is to actually use artificial intelligence to find great investments. And lastly, to use our knowledge to help our portfolio companies become digital leaders in their industry. So this talk is about strategy, and it starts with just some background information about private equity. So private equity is actually a digital, or historically has been a digital laggard industry. But 5 years ago, EQT decided to change that, more or less when I joined. And what we decided to do was really make a huge bet on becoming a leader in digitalization. This is obviously a very kind of broad statement, but we decided to actually try to translate that into concrete goals. And when we did that, we ended up with this, typical set of OKRs that are really ambitious, like being data-centric, using AI, being on the cloud with software as a service, and meanwhile still preserving a lot of this agility, right? I assume a lot of you recognize this situation, but in our case, this was actually quite sincere. So we really wanted to do this. It was not something out of the air. So we did what engineers do. We hit the whiteboard and we started listing a number of initiatives and things we wanted to do. So obviously we had to start with the basics. So with the foundations, we did a lot of ERP implementations, migrating all of our infrastructure to the cloud. And at this point, when we reached the point when we had to work with data, we met the modern stack. And we started thinking about how to shape our strategy around that. So for us, a modern stack is really this new architecture where you have cloud-based data pipelines, a true cloud data warehouse, in our case Snowflake. But most importantly than anything is this piece of software called dbt. And this is where we do a lot of the transformation. If you don't know or you haven't heard of dbt, I strongly recommend you check it out, because our talk will make a lot more sense if you know how it works. But short version, it's really a way to build or to engineer your data stack in a very much traditional software engineering approach, using like a lot of the stuff you usually do when you're running a code project. So having said that, so assuming that we have this modern data stack, we started thinking about how to execute this strategy that I said before, of data centricity and all the things. And we established a pretty large hypothesis here, which was this idea of having the data stack at the center of our architecture. And here I mean not only the data architecture, but really I'll just make a small change here. Not only the data architecture, but really all of the enterprise architecture and all the applications that we want to build. So how do we do that? Well, basically, we established a number of principles, such as saying that every application should expose its own data on the data lake. And we would incentivize teams to actually create some sort of public data API. And this is really this layer of more simplified exposures of their data that others can consume. Anyone could build applications on top of each other's data. So, and everyone was incentivized to do so. Also, all the business logic should live inside dbt, and pretty much every team could use this approach. Why did we do this? Well, because if we didn't do this, we imagine there would be a lot of complexity. So, for example, if you had a team creating some sort of automation based on a set of data, and another team creating reports, we could see cases when they would kind of be building the same business logic in multiple places, and this is something we wanted to avoid. Also, by having a more siloed approach, or like autonomous approach, we would see that teams would build up their data, but not leveraging each other's data. And there were a lot of kind of value opportunities that would be missed because these conversations would not be happening. And of course, this would mean over time a lot of extra code. So teams would not be reusing each other's knowledge, and that would make us less lean. Where with the DBT and the data stack approach, everything would be much more simple, much more well-governed, in the sense that we would have more visibility over the business logic, and the data would be more discoverable, which meant really a kind of a value booster for us. So what was the result? So this was the bet. Then moving forward to today, I'll show you the actual use cases, the result of this. And there are 7 use cases that I'll present now. So when you think about a data stack, everybody thinks about business analytics, and we were no different. So we decided to start there. Not only because there was immediate kind of return in this, but in our case, we wanted to lay the foundation and make sure that we created utility so that the data would be curated faster, right? So we started with the basics: financial performance management, business process management, and started thinking about how would we move towards a self-service future. So this created really this incentive for teams to curate this data API. So as people publishes their dashboards, they start like exposing views and exposing things that can be used. We also one aspect of business analytics is that we also used it for applications, for fueling applications. So not only like dashboards, but also any custom development we would be building, we would try to make sure that this custom development would leverage the same stack. Second use case relates to data validation, planning, and augmentation. So just to explain, these use cases are use cases when the data basically flows through the data stack from the source systems. But then we take that information into an external system where the users can actually edit the data or aggregates and either augment it or do things like creating golden records, for example. So these are actually the main cases. So one use case, obviously, master data management. So augmentation in the sense of creating records that represent the ultimate version of the truth. But we also introduce things like Anaplan for certification of data. So the way this works is that the data warehouse, in the data warehouse, we calculate certain aggregates, we feed them to the system, and then a user goes into the system and double checks whether the aggregates are valid and signs off. So adds kind of a column where we say this total has been certified by me on this date. And then when we push that down into the data warehouse, we can then serve those certifications, those properties, into the business analytics users. So this allows the user to see a dashboard with financial numbers and an indicator that says this has been certified yesterday by this user. Adding these validation cycles allows us to then propagate trust. So create like this sense that the data is actually correct. But it also allows us to do automatic testing on these numbers that are certified. So if I certify that there's $1 million on a certain GL account, I can then do a test that checks that that aggregate number didn't change due to some code change. So Next use case has to do with AI. For us, AI, when we talk about AI, we talk about MotherBrain, which is a product we developed internally. And this is a product that helps us find people and companies to invest in using machine learning. This is used on a daily basis by our investment professionals, specifically to basically help them collaborate and evaluate opportunities. We have identified 9 companies and deployed in more than $100 million in investments. This is powered by 40 data sources, and we are tracking about 14 million companies using this. So, of course, there's all the machine learning activity going on, but I think for the data stack, the relevant element here is data preparation. So in the past, what we did was actually to do a lot of the data preparation and feature engineering in flight. So as you consume the data, you would kind of try to make some decisions and create certain attributes that would then be feeding these models. But we changed that when we started using DBT to do that on top of the data that was at rest. So the way this works is that you have like all your data on the lake, and then you run these jobs that create columns that represent these features that we then feed the models to. This has allowed us to basically create a history of our hypothesis in terms of feature extraction. So we have source code that says, how do these features work? And it allows us to apply the newest thinking around features to data sets that have been ingested a long time ago. And this allowed us to do things like go back in time and check, would I have found this company given the data or the information or the algorithm I have now and the data that I had at that point in time. This is very interesting and greatly allowed us to really speed up the iteration of our teams and be much more thoughtful about how we do feature engineering. Next use case has to do with feeding bots and integrations. So how do you feed a bot? Well, basically a bot is a system that requires some sort of activation criteria. Typically, if you build a bot or like a standalone application, you can do that by checking a service bus or by making an API call to a source system. But what happens with that approach, or more like siloed bots approach, is that your business logic gets spread across a number of applications, and also you need a lot of plumbing to make it work. So instead, what we did, we flipped that around and we said, okay, let's create these activation criteria, these filters on our data directly on our database, on our data layer, and then use that or build the bots on top of that. So, for example, if you have a bot that is doing notifications, the bot will be checking on a view that we have created on our data warehouse. But you can actually have another bot that is doing very similar information with the same data set. One of our favorite use cases or sub-use cases for bots is a thing we call MotherBrain as a boss, which is a functionality that basically grabs the highest ranking or highest scored companies on a daily basis and sends it over to our investment professionals for review. So they basically get this list of companies. They start checking and saying whether they like them or not. This allows us to not only streamline their work, of course, but also to get really interesting feedback back to our machine learning models. So another use case is a computation engine. So this is fairly similar to the augmentation use case I described before, but it serves a slightly different purpose. So the idea is still this one, that you basically get your data from your source system into your data stack. Then you take that data out and you do things that the source system is not able to do. So, for example, instead of buying a system that has really good dashboarding and really good customization capabilities in terms of doing certain math. You buy a symbol that is simpler, or a system that is simpler, but then you create these external applications that reach these use cases that were not served by your initial system. Okay, so in our case, we have made a choice to go with a simpler HR system, and then we do certain things like reporting with some external data using our data stack, or we do some calculations, some complicated calculations we have around salary data also externally, and then we feed that data back into the system to do like other business processes, and we call that reverse enrichment. The key insight here is that this architecture allows us to go for a smaller applications, and thereby being much leaner and faster in those projects. Use case number 6 has to do with ingestion of complicated formats. So EQT is a very large consumer of banking data. So we have something like 3,000 bank accounts across a number of different banks. And even though the way how we get data from the banks is actually standardized, so we have open standards that are kind of adopted by all the banks, the reality is that each bank has its own interpretation of those standards. So we ended up in a situation where we had data pipelines parsing the data coming from the banks, and we had a lot of custom code that had to be built to process this data in flight. So recently what we did was we changed that, and we said, okay, let's just ingest the data as is from those banks straight into the database, and then apply the concept of schema on read, so the parsing of those formats in the moment when we try to read it. And this allows us to model everything as code, and be able to apply the latest interpretation of those formats also backwards. Okay. So this greatly simplified. It allows us to have much less code to maintain and to start exploring much faster. So we can ingest the data really fast and then not worry too much about the ingestion piece. Just let the data be there and then start playing with it faster, and before we decide how we want to approach that specific data format. As a bonus note on ingestion, what our stance here is that we are trying to always go for the more commoditized or the less complex approach to data ingestion. So here on this picture, you can see from the left to the right. On the left side, you have classic processing of data pretty much in flight. With more modern tools, you can have some sort of visual coding that commoditizes parts of the exercise. For example, commoditizes the connectivity to your sources. Then on a next level, you have companies that actually do the whole thing. So they take care of extracting the data and loading it into your data warehouse in a fairly normalized manner. And more recently, we see basically this whole pipeline thing being shortcutted with things like data sharing. And we actually started using that. And the benefit for us is really that we don't need to worry about parsing of any formats. We just start immediately consuming the data the moment it is made available as a table for us. This allows us to focus on the data and much less on the actual ingestion process. And the last use case here has to do, it's actually one of my favorites, has to do with customer-facing portals. So our thinking here is really, when you think about a customer-facing portal, it's really about serving data that you already have on your back office, right? So in our case, our investors, they want to log into our portal and see, their positions, how much they've invested and whatnot. We do not have a lot of transactionality, like investors trying to do things in the portal. So it's really more of a read-only use case. And so we saw this trend in the market on headless CMSs, and we asked ourselves, why don't we make our data warehouse a headless CMS to serve the channels. So we tried that, we did that, and what we have is basically our portal reading data from the exact same views that are used for serving our internal management reporting, for example. So there's a lot of business logic that is shared. The only thing we need to do in order to approach these use cases is to ensure that we have things like data certification, so locking and unlocking of data that we want to publish. But that's kind of a variation of the use case I mentioned in terms of data augmentation. So really like having a layer where someone goes in and checks for things. What we see with these use cases is not only like the simplicity of having everything go through the same pipe, also the ease with which we can use the same data in multiple channel settings. So you can have like a web portal, or you can have like a more messaging notification engine using the same data. But what we see as a huge benefit is that as you add the utility and you add more eyes to your data, the quality starts going up. So you're all of a sudden your portal team start challenging, okay, why is this data not working so well? And it kind of trickles down this data quality exercise, and that's a really good property for us. So that was the last use case, and wrapping up now. Going back to our initial hypothesis of putting the modern data stack at the center of our architecture. I mean, the key takeaway here is, people talk a lot about data culture. For me, data culture is when you actually see data being used in production settings, right? So when you create an architecture that incentivizes teams to build stuff, and of course, when we started, we had no idea of the amount of use cases that would come out of this architecture. But a couple of years later, we see, tens of different ways to do this. And that is really what as an enterprise architecture, we consider a success. That said, if you want to try to do this, it's very important that you acknowledge that there are certain caveats with this approach. So, for example, this approach is super sensitive to data quality. So, if you don't fix that very early, you will see that all these use cases will have fragility. Also, latency issues. So, if you want to do, for example, bots that are very close to real time, this approach typically is a bit slower because you have these cycles of data ingestion, data processing, and whatnot. Also, documentation is super important. So you will see an explosion of views and business logic being created, and it's very important that you have some sort of governance around what to use and a very good structured approach to your data model. But that said, I mean, this was truly a data culture enabler. So we see our teams, that usually wouldn't be talking about data modeling, sit together and say, okay, how should we model this concept? Which system should own that? So there's a lot of really interesting benefits there. Of course, an innovation multiplier. So the value we get out of the data is truly unique. And most of all, I think we actually achieved our goals that we set a few years back of being data-centric, having process automation, having simplicity and speed of iteration, and a lot of flexibility as well. So thank you very much. If you enjoy this talk, I would love to hear from you. And of course, if you like working with this type of stuff, just reach out. We're always hiring people to work on with us on these challenging projects. So hope you enjoyed. And I'll just quickly check if there's any questions here. I do have one. I think, let me see if I understand. John Lind from Informaticas. Okay, so there's a couple of questions around lineage So I assume it's how we understand how the data flows from your ERP system, what's the processing that is done all the way up to the consumer level, right? So this is an interesting question. I think there's a lot of software approaches to this nowadays. So at the core, what we have is, because we use DBT, DBT shows you a very comprehensive lineage charts. So it shows you, there's a concept of exposure, where you can see, okay, this consumer of data, what are all the tables that are contributing to it? And you can have things like metrics around freshness of that data. And what we are trying to do is actually augment that information with metadata around ownership. So we try to identify, okay, this person is the owner for this exposure. So, they're ultimately responsible. But we do have challenges, for example, around the propagation. I think you mentioned something here around, what are the different transformations and consent. Yeah, definitely complicated. The true answer is basically you need to look into these use cases and try to engineer something that works for you. Okay, so there are no miracle or silver bullet solutions here. And yeah, I don't think that I have any more questions, but anyway, I'll wrap it up for now. Feel free to reach out. Happy to engage in conversations with all of you. Thank you very much.